Removing 1 milligram of material is now a thing of the past. I believe we must continue to surpass our own records. With upgraded equipment and new materials, the machining space has become narrower, and our drill bits have become even thinner. I hope each of us can achieve a higher level of precision and independently solve complex problems. To me, that may be my greatest achievement. Imagine dividing an A4 sheet of paper in half. One half is about 0.05 millimeters thick. That 0.05 millimeters is exactly the size of my tool, the diameter of the blade on this milling cutter. When removing the protective cover, your hand must remain absolutely steady. Even the slightest tremor can damage the blade. During clamping, the large machine, dim lighting, and the near-invisible blade make it impossible to rely on the naked eye, yet its path is clear in my mind. The milling cutter must be completely stable during operation. Even the smallest vibration can cause significant deviations. A blade only 0.05 millimeters thick requires complete mastery to handle. It moves like a dancer, lightly tapping across the hard metal surface. Each pass removes just 0.001 millimeters. From starting with nothing to now working with confidence, after hundreds of steps, the accuracy of each cut must be controlled within 0.05 millimeters, or the task will fail. Look, this channel, with a diameter of 0.06 millimeters and a mirror smooth surface, has been completed. This tiny passage is the tunnel through which satellites transmit microwaves in space. I understand that a millimeter of precision determines whether the eye of space can observe distant landscapes thousands of miles away. With skilled hands, Zhang Zhejiang can carve the eye of space and tailor protective golden thread armor for deep space equipment. Spacecraft rely on internal radar transmitters for precise positioning, and these core components are protected by a carefully crafted shell capable of withstanding extreme temperatures and pressures in space. Since the first generation of Shenzhou spacecraft, Zhang Zhejiang's team has been responsible for safeguarding these critical components. Sometimes I tell my children that some of the parts on the satellites flying above were made by their father, and I feel truly proud. But I am not yet satisfied. The weight requirements have already reached their limit. There is a saying in aerospace, every gram saved is a contribution. But for Zhang Zhejiang's team, reducing even 1 gram can feel nearly impossible. This time, the design drawings already pushed to the limits of weight reduction require the shell thickness, originally 5 millimeters, to be cut in half. When it seemed impossible to reduce the weight any further, I felt I had to challenge myself. You cannot back down when facing difficulties. Problems don't solve themselves. You have to break them down and tackle them step by step. After machining, the part would often become deformed. The thinner the shell, the more easily it deforms, a challenge widely recognized in the industry. With unfamiliar new materials, preventing deformation becomes even more difficult. In the beginning, the deformation rate could reach 60 to 70%. I also had to carefully consider the machining sequence to release internal stress. Over the years, Zhang Zhejiang has continuously refined his skills with strict, repeated practice. He never sets limits for himself. Through enduring solitude and repetition, he has developed a deep understanding of materials and their behavior. The first requirement is meticulousness. The second is the ability to grasp extremely subtle details. With a drawing in hand, and based on materials we've used or seen before, we can generally determine the machining process.
我觉得这个就不太好，你可以看看。我觉得这个圆角的地方最起码跟这个要再差3到5次。
Zhang Zhejiang can identify micron-level deviations at a glance almost equivalent to professional measurement results. For example, the difference between this rounded corner and the straight line is about 0.05 millimeters. Right, that's why I say you must keep these details in mind every day. Each time you look at it, you confirm it again and again. After 10 or 20 years, your eyes become trained. When I see a part, the numbers appear naturally in my mind. This precise confidence comes from more than 20 years of calm focus, hundreds of custom fixtures he designed, and over 50 innovative achievements. After more than a year of work, while ensuring structural integrity and precision, the thickness of this protective golden thread shell was reduced from 5 millimeters to 1.5 millimeters, cutting its weight by more than half. With this, the nation's deep space equipment travels through space with greater efficiency. Innovation is not about doing something simply because it is small. It begins with small breakthroughs that gradually become more refined. We must turn these small innovations into major advancements. The original intention is simply to do every ordinary task well and honor every product you deliver. A ruby probe with a measurement accuracy of 0.001 millimeters. A difference of 1 millimeter can affect the precision of critical national equipment. A single program, several cutting tools, and an aluminum alloy blank require thousands of tool passes to carve features 100 times finer than a strand of hair. The tool path forms a continuous line that can extend up to 500 meters. Its structural complexity is comparable to that of a sophisticated circuit board. Tens of thousands of tool paths have been rehearsed in my mind every step, every tool change, all encoded within this tiny square of space. I spent 2 days designing this complex program, capable of carving 2, 10, or even 100 identical walnuts that could all pass the ruby probe test. From carving walnuts to supporting aerospace, my work lies in this microscopic world, compensating for errors through various algorithms to ensure precision. The largest part we make can be the size of an elephant, while the smallest is no bigger than a peanut. He Xiaoxiang's work spans extremes from controlling massive castings to carving grooves finer than a strand of hair. His tools are the CNC programs he writes himself. I think this level of programming is like playing chess. I can only think 2 or 3 moves ahead, while he, figuratively speaking, can think a dozen steps further. Coming from the Luoyang Mountains, he Xiaoxiang carries a natural simplicity and determination, becoming deeply absorbed in perfecting CNC skills, carving on walnuts, engraving words on eggshells. Then came a national mission to manufacture a key component for major aerospace equipment, the spiral shaft. It is only the size of a peanut, yet requires 10 times the usual precision, reaching 0.02 millimeters, something never achieved before. That level of accuracy is comparable to the size of 2 bacteria, visible only under a 400 microscope. To what extent, even a drop of water on its surface cannot seep in. The requirements are extremely strict. The greatest challenge is that the spiral shaft has 6 grooves, each requiring different angles and precise meshing, making it the most complex part of the process. We experimented repeatedly, testing different tools and parameters over and over. Beyond fine craftsmanship and the right cutting tools, the most critical element is the complex programming process. The programming world is vast and abstract, and I must debug hundreds of times with an allowable error of only 0.01 millimeters. Each program takes hours to complete, sometimes an entire day. This programming method is a unique approach I have developed over several years. He Xiaoxiang spent more than 30 days and nights repeatedly reviewing and testing the program, with each fine-tuning requiring the revision of dozens of previous calculations. He is not only working with cold code and metal, but also engaging in a long, meticulous contest with extreme precision. Through persistence, he pushed the margin of error to the very limit of manual capability. I believe my greatest motivation comes from genuine passion for CNC machining and CNC technology. Don't tell me something can't be done. I simply want to make it happen. That determination drives me forward. This almost obsessive pursuit makes even the smallest progress meaningful. A month later, He Xiaoxiang finally achieved a tenfold improvement in accuracy within the highly complex microscopic domain, laying a solid foundation for the successful launch of a major national project. During the National Day military parade, seeing so many important national defense systems pass before Tiananmen Square and appear before the world filled me with pride and strengthened my resolve to work faster, with greater precision and at a higher standard. In 2020, at the age of 27, He Xiaoxiang used his advanced programming skills to lead the team in building China's largest automated production line for aviation-related systems. The place where I work now is where China first produced such systems, and many key national defense components are shipped from here. In the future, I hope that through the efforts of our generation, with higher levels of automation and intelligent manufacturing, we can create more advanced, more refined, and more efficient equipment for our country. To strengthen national defense and contribute to the nation, that is our mission.